Hello. I tried it, I thought. Hello? Ah, there we go. Speak into the microphone, it works better. Oops. Oh well, there went my, oh come on. I just hate seeing that blue screen, man. So anyway. Get started. Is everyone here? Okay, everyone's sitting down. Okay, let's go for it. Hello, folks. Everyone with a heartbeat, raise your hand. Okay, so there were a few down. Hopefully rigor mortis doesn't set in too soon. How many people here actually do use Docker for anything now? So, okay, some people have seen it. I guess everyone uses Perl for something, right? Okay, so we can. Yeah. I'm sorry. The Python guys are across the street. We'll corrupt your mind. Stay here. One of the things you notice about the Perl that you find in a lot of distributions. This is taken from Red Hat. Anyone here use Red Hat Enterprise 7 anything, RHEL? These are the compile switches from Perl-V. Notice that today they're just distributing 5.16, which is end of life. Nothing more recent. You also note that this really isn't tuned to be very effective. It's still compatible with 5.005. And even if you don't use threads, you've got threads. This is a bulky, slow mess. People wonder why they can't get things done with Perl, because they're using the native Perls on the distributions. Docker gives us a good way to get access to your own Perl. So something what I'll show is to get it for your architecture so it matches your hardware, get optimization in, get only the dependencies you need or want. The great thing about Docker, because you can build umpteen Perls and try them, you can see what the switches do, you can play around with it and get something optimized for you. But it's not obvious. One bad approach that we've all used for quite a while now is things like Perl brew. Let's see what happens if we do this, and use virtual machines. How many people here like using virtual machines? You enjoy booting things over the net and having them not boot right, and certainly it's fun when you have to deal with library version hell on different ones, and having to deal with Chef and Puppet to change all the version numbers of all the different things. That makes it so much easier to program Perl, doesn't it? So that is false laziness. It is not lazy to have to do something over and over painfully. So LXC is, how many people here remember LPARs? Okay, there are a few of us that use cards. How many people have plenty of bookmarks sitting in a closet somewhere that you, an LPAR was how you, oh, I'm sorry, I thought it was picking me up better than that. The LPARs were the way that IBM mainframes used to split up the CPU. Basically what IBM did is they took some things in the Linux kernel and ported some IBM 360 technology into Linux. And the trick there is, instead of creating a virtual machine, let's isolate the process. Berkeley Jails tried to do this, Solaris Zones tried to do it. The problem with those is they only ran on things that most of us aren't using anymore, and they didn't work all that well. Again, the idea is to share the kernel, but separate each process into its own space. At that point, the processes are a lot lighter weight than virtual machines. Has anyone here ever tried to really use LXC when it came out? I mean, you sat down. Did anyone read all of these? No. That's why no one ever used it. I mean, just getting through the configuration for LXC, it's all in there. It will do everything you need it to. But it's like trying to learn electrodynamics to dial a phone call. So Docker came along. Basically, this is an MRE for Linux. It's an 80-20. Docker does not do a lot of the things that people need it to. It's not finished yet, but it works, and it works well enough, and it gives us the ability to get what we need now. So that's why everyone, I guess, is picking up on it. The problem is they start out with Ubuntu as their base image. Everyone ever look at the Ubuntu base image and seen how large it is? At 1.6 gig, you've got to download it every time it changes, every time you're starting up on a new system. You're sucking that in. And let's think about the things that your Perl program might need available to it to call from the shell. How many people call grub from within their Perl programs? How many people use LVM on a regular basis from inside their running Perl programs? How many people have an Apache website that calls LVM and creates new volumes based on what people pass in, right? Do you do much with managing the MD Atom, managing your virtual drives from inside a Perl program? Ubuntu is a waste. You're not going to use most of these system management and X11 tools, so you've got 1.6 gig of stuff that you can't use and don't want. So this is a Perl conference, so I'm going to show you more than one way to do it. The basics begin with a Docker file. Docker uses these to define how it builds an image, which is one way to go about doing this. So the trick will be to set up a Docker file that will build a stable Perl for you without all the weight of Ubuntu. Another way is to copy Perl on top of BusyBox. The trick there is you build the Perl, stick it in an image, and have just BusyBox underneath it. What's great about that is if your Perl blows up for some reason, with BusyBox you've got a shell to go into the image and inspect it. You've got just enough tools to use it, but it's only 1.5 meg. It's not an entire operating system that you don't need. And another way to do it that I'll show you is just to shove Perl in an image, Perl and nothing else. If the image is blown, you have no way of going in to find out because all you have on this is Perl. But it's great once it works because if you're doing something like Plaque, it may be all you need. So the first thing you need is to get Docker. One way to do it is apt-get or emerge. I use Gentoo, Yum, whatever your favorite tool is. A lot of those have problems because you've got to make the kernel right for LXC in order to run Docker. And the pre-tests from LXC, they run and they tell you missing something, but they don't tell you the kernel switch that's missing. So you go into the config file and you get no idea what to set. It is one of the most, why they didn't say we checked for this and it was missing, I don't know. If you use curl or wget to grab this thing from Docker, it's a shell script that will do the stuff, and it actually gives you better error reporting in a lot of cases. It used to. I haven't run this in a while. But this will bypass any issues with precompiled stuff on Red Hat and Debian-based distributions, and it goes in and allows you to compile it on site. For Gentoo, it doesn't do much because Gentoo, you can compile it anyway. One other thing that I see people, this is part of the documentation from Docker. Please don't use SU to run Docker. You will shoot yourself in the foot. One of the wonderful things about Docker is that you are super user when you're inside the container by default, but you're not on the outside. Don't make it so you can blow your kneecaps off that much more easily. We all have enough problems. If you add the users that are going to run the Docker commands to the Docker group, you've got some minimal security because then only the people that are in that group can run Docker, and you don't need to be super user on the outside to run Docker. Once you've done that much, if you type Docker PS, you should be able to see lots of nothing, but you won't get an error. Until you can do a Docker PS, nothing else is going to work. That means start the daemon, make sure that it's all set up, configured. If you're going to use Docker's repository, one of their little gotchas is that they have a free repository, and you can put a certain amount of stuff on it. It's all out there. It's public. You can have private repositories if you pay for them. And that's what they want you to do, is pay for the private ones and then have so much stuff stored on it that you pay them for storage. You can also run, and there are great Docker images for running a private Docker repository. If anyone wants, I can show you what those look like. And that allows you to run the thing on your local host, which saves you a lot of download time. So to begin with Docker, for the people who haven't used it, grab a copy of BusyBox. People know what BusyBox is? Seen it? Used it? Okay, well, it's a single executable that has the 80 things in it that you really need to survive on an OS. It's got a very minimal stripped-down VI. It's got a minimal version of SH that does basic editing, LDD, the day-to-day commands that you use to try and fix a broken machine are there in BusyBox. And it will install itself by hard linking all the names it can be used as to itself. And generally, BusyBox is a nice thing to have around because it allows you to play around inside that container and see what things look like. So if you start up with BusyBox, you do this thing. If I do a poll, this shows you what it looks like. These numbers here are hashes that Docker uses to identify everything. To run it, the -T and -I says, give me a controlling terminal. I want this to be an interactive shell, basically an interactive container. When I do this, I will be in BusyBox. One thing to notice, you are super user inside the container by default. This will affect things you do with Perl, because Perl doesn't always like to run as super user. There's docs within Docker on how to set up real users in a container, how to set up an image that's got user IDs, how to become that user once you're inside. You might want to think about that if you're going to run Perl, because again, Perl, there's a lot of things that it doesn't like about running a super user. When you're in the box, you get a certain amount of minimal networking. I'm not going to go into, this isn't a Docker class, so I'm not going to go into all the things it doesn't do right. But when you exit, you're back at your original user ID. One thing you might want to do, and I'll do it in these, is if you add with the -T and I up here, a --RM, that will remove the container from the active process list, and it helps you clean things up a bit. So everyone here use Gentoo? Or have seen it? So people are familiar with it at least? So the basic idea is it runs a lot like BSD. You compile everything locally. What's neat about that is the base image doesn't include anything really other than basic shell commands and a build environment. It's got GCC and make by default. What's important about that is I can use it to build Perl. But it doesn't have grub, it doesn't have VixieCron, it doesn't have time daemons and X11. You have to install X fonts, so it's much lighter weight than Ubuntu is to begin with. So this is an example of I can go to registry.hub.docker.com. That is where you store things. Looking in the public portion, I can find a Gentoo Stage 3. That one was reasonably current, so I used it. It's a little less than half the size of Ubuntu. Pull it down. Again, I can run this. If I execute it, I'm running a copy of bash inside this thing. You can check the GCC version. It's current. And the nice thing is this supports arch=native. So it will do everything it can to optimize the Perl I'm building with it for the hardware that I'm actually running on. If you look in GitHub, there are templates for building different versions of Perl with different optimizations and threading and all the rest of it. So you can grab one of these. And again, this is Perl 5.02. It should have been 20, but typoed that, sorry. So I grabbed a copy of this, and this is what a Docker file looks like. Most of these directives are reasonably clear. The from says the way Docker works, because it stacks images, this build pack depths will be the image that is stacked immediately below this. And that may have images under it, I don't know, however many there are, but that's the starting point for building this layer. This guy obviously was running on Ubuntu. He did an apt-get. You can see here he made Perl, changed to it, slurped a copy of Perl down. Now, one thing a lot of people do, I notice in Docker files, they do all this double ampersand stuff. Every time you put one of those double ampersands and you create a new process in the cycle, you're going to create a new intermediate image. You don't escape creating intermediate images with double ampersands. He could just as well have had 5 run lines that would have been a hell of a lot easier to read. But he did this configuration. made everything, and then did a make very clean. Then he set himself to root. That means when you run the container, this is the directory you'll be in. And he set the command to Perl whatever. So you're going to run what that's going to run is bin sh, which is the default entry point, and it's going to run a copy of Perl 5. The way he did this, because he installed into the standard bin lib directories, he overwrote the Perl that would have been there already. So if there was a Perl 520 that came installed with the OS, he just stepped on it, which is something I usually don't like to do. So I'm looking at the Perl that I have already installed on this machine. I've got a prefix, I've got optimize with -03 in arch-equal-native. Or I can do the same thing with a Perl -m config. If you wanted to automate this, use the Perl -m, because you can actually write a fairly simple Perl program that'll do all this for you automatically. And this gives me a new Docker file. I'm going to go to var temp. I'm going to slurp up a copy of Perl 520, or now 522. And I apologize. I left a new line out of here. I'm then going to feed it into gzip and then slurp it out of tar. Man, I botched that one. I apologize. That backslash shouldn't have been there. And then gzip it, tar xvf. At that point, I can cd, do a configure. One thing I'm going to do to save space, inside of a running container, are you ever going to run Perl doc? Probably not. So let's turn off the man pages, save some space. And I'm going to optimize it. I'm going to run make all test install disk clean, run h to ph, and my command is going to be Perl -d -e42. Newer versions of Perl, the uppercase E turns on all the things, so you don't have to do use version to get things like say or whatever.
And 42 is a better number than 0.
Yeah, well,
The answer.
yes. So when you're building things with Docker, you run a Docker build. You can give it a tag, which is the name it'll have in the repository. And then you tell it the directory that contains the Docker file. You don't actually give it the path to the individual Docker file. Everything that's in that directory will get slurped and is used to produce the final image. So you can see here in a previous case, I was running this, doing Docker images, lists what's there, and I don't have a tagged image. I've got all these nones. You can see the different stages of whatever it was running. The thing about those is each one of those, because it saves a stage in the build, they're reusable. They're a cached copy of the output of that stage. So if I have to restart the build, I don't have to redo them. So let's say I run this, and the original version of this, I botched one of the commands. I did a -r, -a, -l, and h2ph compute. You notice here it said using cache, using cache. It reused the previous stages. It didn't go through the motions of rebuilding Perl. I'd already compiled it once before. But I botched the h2ph command, so it stopped there. Easy fix, change it. Now I rerun it. Now, all test install reuses the cache. The image is already there. It doesn't get rebuilt. I rerun this one, and at that point, rerunning the build takes, 0.2 of a second, 1/4 of a second. That's one of the neat things about Docker for this kind of thing. If you're testing something, it's a lot less painful because I didn't have to re-wget it. I didn't have to download things. It can make it nice just for testing environments if you want to see, does this work? So now, looking at these, the Gen 2 Perl was 884 megabytes, which is not trivial, but at least it beats using Ubuntu. Do the math, it's 100 and something meg for a bare copy of Perl. BusyBox, by comparison, is 1.9. So I used an extra 740 meg to have this based on an OS. If I run an rm-rf to get rid of that build directory, notice that my final virtual size is the same. That's one of the catches. When I did that wget of Perl 5 and I did the build and all the rest of it, anything that's done that creates an intermediate image is part of your virtual size at the end. So be careful what you stick in there, because there really isn't a way to get it out at the end. You may not and you have to ship it around when you start up Docker on a remote machine. So that's where that dist clean came from, is it saved me all of the space of the intermediate content in the Perl build directory. When I run the command, I do an rm-i-t, and I see the Perl debugger. So it worked. But it's big. Now, right now what happened, that ran bash with your command when I started that container. I can change this with an entry point. The entry point is the thing that processes the arguments passed on the command line to the Docker run when it gets executed. I could change the entry point to run Perl, and then my command is DE42. At that point, if I do this, it's kind of neat, because then I can run Docker run and the name of a Perl program, and it will pass the Perl program to Perl and just run it. Or I could do prove or something else. So at this point, I can do just Docker Perl will get me back into the debugger. And the only real advantage to that is it saves people from typing opt Perl bin Perl on the command line every time to start Docker up and get Perl running. So now what I do, I can create a stacked image. Now if I want to run this Perl, I would do something more exciting than just run the debugger for the rest of my life. What I'll do is create a new Docker file. It will come from this Gen 2 Perl, and the command will be whatever the path I put in the image is. Because the entry point is opt Perl bin Perl. Perl will run the thing, and I can run an application. So this is the path to my Perl code might be a Plack application or a Plack server or Dancer or whatever you want to start up. Another neat thing you can do with Docker is you can avoid shipping out tests. Has anyone here ever been at a place where somebody ran a test they shouldn't have run, like a destructive database test in production? They type prove by mistake and they nuke things. Distributing your internal tests with your code is usually a way to fry yourself. A great thing you can do with Docker, have one image with your product. Have a higher up image derived from it that has your tests. Execute the container with the tests in it, you'll run the tests, but then you only ship out the container that has the product. That allows you to ship out a product without having tests in it, which can save a lot of trouble in the real world. Now, you've seen how to do this, you've seen how the Docker file works, but to a large extent, this is a waste of space because Gen 2 is still too friggin' big, and I don't need a copy of GCC in my running application. If I'm running a Plack server, how many people here call GCC from within their running Plack server? Or make, for that matter. It doesn't, it's not something, the reason people do it this way, we're all used to virtual machines. We can't get away from the pain. It's like a heroin junkie. You just need one more fix to get off of it. So another way to do this entire thing is to build Perl on top of BusyBox. So if I look in the Docker file and it comes from BusyBox, I have the same entry point, the same command. Now I can run an entry point with binsh and use BusyBox to check it. I won't use bash. But I get a much lighter weight thing. Building Perl on top of BusyBox is 67 meg, only 1.9 of which is BusyBox. So which would you rather ship over a slow network connection? 884 or 67? Then the 67's just core Perl. If I wanted to have a reasonable number of modules, Perl easily gets up to a few hundred meg if you've got a reasonable fraction of CPAN installed. So I might be shipping up 1.5 gig every time I push something around, of which 884 megabytes is something that I really don't use most of. The only reason I've got that whole 884 was to have the libraries. So what I can do, instead of doing a run to build a copy of Perl, what I could do is just build Perl on my local system. Do it the normal way. Put it in opt Perl 520, have it running, check it out. What I would do then is I would cd to the directory that's got Perl in it and copy that into the image. And the copy command is one of the standard ways to do it. I can still use a Docker file to build this. It's still wonderful and holy and has a way to redo it. But now my Docker file is four real lines long. It's built from BusyBox, and I don't have to have an entire OS underneath, and I can build the thing at my leisure. I'm not having to build it inside of Docker. So, for example, one of the uses for this would be if opt Perl 520, I can install, if I install a new CPAN module, if I do a regular CPAN upgrade, I've checked out all my modules, I want the new modules, I can rerun this in 30 seconds and get a new image to ship out. I don't have to recompile Perl from scratch every friggin' time I want to update the CPAN modules. So, then it gets down to, let's just say your normal copy of Perl. A lot of times you got CPAN Reporter. How many of us run CPAN Reporter from inside of our plaque? There's still stuff in core Perl or things you use on your distribution you don't really need. So the next thing is, and this is actually how I do it, one day I extract a copy of Gen 2 Stage 3 into a scratch area. I chroot to it and build Perl. And that is the bare copy of Perl that I use to make images from. I don't install CPAN Reporter in it. I don't install everything everywhere into it. I install what I need to put in the images. Then all I do is I cd there, and because it's chrooted when things are built, I can cd there from the outside world. I don't need to build a relocatable Perl. I can do a copy dot into the image, and everything's in /opt Perl. If that didn't make sense, try it on a piece of paper one time, you'll see. But now I've got an opt Perl that has only the modules I need in it and no more. But I can still have another copy of Perl out there that I test things with. This thing is only for building Docker images. And in today's world, kissing off an extra gig of disk space in a corner for something isn't going to kill you. Another way to do this is dodge the Docker file entirely. If what you're going to do is run a plaque server, you probably don't even need or even want BusyBox, because you don't want people to crack into the container and have the BusyBox tools around to screw with you. You might not want people to have a copy of the shell if they crack into your container. At that point, if I cd to wherever my Perl distro is, I can create a tar image of it and use Docker import. Docker import just slurps in a tarball. So what I do then is, oh God, I left a character out of here. There has to be a dash in here. God, I really blew this one. But if I create a tarball, you use the -change switch. Don't ask me where they got it. And that allows you to put the kinds of things you would stick into a Docker file and have the import process them that way. This gives me an image which has no parent. It just is. It's a bare, naked copy of Perl, and I've tagged it. If I were running plaque and this had a directory with my plaque service in it, the plaque execution code, I would have nothing I didn't need. There's only one problem with this approach: it won't run. Most of us build Perl with shared libraries, and if all I do is copy opt Perl, I don't have any shared libraries. In my case, all the shared libraries came from lib64. So Docker gives us a way to deal with that, with what they call volumes. And this is basically a bind mount inside of your container. So if I do a Docker run with this -v string, I've said take the lib64 on the main OS, stick it into my container and make it read-only. Now Perl will run. And the nice thing is, if I'm running this on my local machine, I don't have to package a bunch of libraries that are already on the disk. In fact, if I had a plaque application that used my local copy of Perl, all I really need to make an image of is the plaque application, And I can do a -v opt Perl. And it can reference shebang opt Perl bin Perl, and it'll be using the one on the disk. You don't need to virtualize all of this. We're all still too used to using virtual machines for everything and shipping around a lot of stuff we don't need to. So this -v switch gives you a way to have nothing but Perl, just the bare minimum of what you need in the container, or even less. Keep Perl outside the container and have just your application in it. So you can create an application that is nothing more than a one-line shebang script that executes something and has everything else mounted bind from the outside world. The one trick with this is if you're going to use this lib64 trick, you've got to have a homogeneous environment or you can't ship this to multiple machines. Or at least you've got to have enough of the same libraries that Perl isn't going to keel over. If you run it on one of the remote machines and it's got out-of-date libraries, you're going to have a mismatch in the library versions. So that can cause you pain. Another neat trick for this, by the way, if you're running a server and you need scratch space, before you run the thing, if you make dir var temp $, you can bind that to var temp inside the container. And that gives you a nice scratch space on tempfs or whatever your fast storage is that's private to this container. And just remove that on the way out. The other thing you can do with this, if you don't like the -v trick because it feels funny, LDD will give you a list of shared libraries. There's nothing that says the images have to be stacked in the order they're used. So I can go in after I've built Perl and after I've got the Perl image, I can run LDD on it and see which libraries it uses. I can create a new image with those libraries. Just copy them in to a new image derived from Perl. As long as the libraries are there when I try to run Perl, it'll all work. So you don't have to derive the libraries before you build the Perl image, do it afterwards, and ship that out as one unit. And then you don't need to use the -v. The other way is build Perl static. If you're using your Perl to drive testing of other things that might be in the container, having a static Perl is easier because then you're not dependent on the libraries of the things you're testing, which is a situation I get into because I'm using Perl to test other people's code, and I can't guarantee what versions of libraries they might need. And using a static Perl obviates all of this because then you just ship the Perl and you're done with it. But then you've got to, with static, you're shipping a fair amount of data. Either way, you can get a very small portable Perl that's no bigger than what you need just by not including more than you have to. For experimenting with Perl for a development environment, I'd recommend start with BusyBox plus whatever Perl and then run it with the -v. You can build the Perl container in minutes using copy, have something running. If your question is, does adding this new CPAN module fry me? You can copy it in someplace, create an image with the CPAN library, make this copy of Perl, try it. If you don't like it, back it out. But you could build the Docker image to test the new CPAN library in minutes. And docs.docker.com is where to find things on Docker. Again, a lot of their documentation is a bit simplistic. It assumes that you need Ubuntu. Really think hard before you add stuff to these images, because once you can see from building it, if you put junk into an image you don't need, removing it doesn't make the image smaller. And it means you've got to ship around stuff that even if it isn't loaded into core when you run, still has to be pushed into repositories. The other thing I'd recommend, just because it makes life easier, go to Docker repository, and there are a number of Docker images of a Docker repository, and then you can run it local. So when I built all of this, actually, I had to slice off localhost :5000 from the front of these, and then if I actually did a push, it takes 3 seconds because I'm pushing it onto the local machine. And you don't have to worry about outside access, and you don't have to worry about whatever level of security they might have, and you don't have to freak out about whether you might have something someone might break into Docker's hub and steal from you. It's all local. And that's it. The basic thing to remember, Docker it's really not a replacement for LXC. If you need all of LXC, don't use Docker. But it'll get you through the 80-20 type thing. You can probably use this for most of what you need to today. And because it's still evolving, if you don't like something, scream at Docker because they have made a bunch of changes in it to accommodate what people liked. And yeah, the trick with the -vlib64 allows you to distribute Perl without having an entire OS underneath, which will save you an enormous amount of pain. And that was it, I think, yes. Any questions or any rotten tomatoes I can dodge? I don't know. What?
Okay, you're suggesting that at one point to build Perl stack.
Yeah.
And what does that imply for traditional modules, say DVD MySQL?
You'd build them all static. Well, it depends.
Yeah.
If Perl is built static, that doesn't mean that the other ones have to be built static. But you're not going to get the benefit of not having to use the -v. The whole point of building it static would be if I've got a completely heterogeneous environment. And I'm trying, for example, in my case, my current client, a company called Early Adopter Labs, we're doing testing as a service. So I drive the tests using Perl. But that means people give us stuff to put in the image that's being tested, where I have no control over what OS they want to use and what versions of any libraries they want to use. If I want to use my code on top of theirs to drive the test, it has to be compiled static because I got no ideas what libraries they want to have. And I can't run the risk of masking one of their libraries with one of mine.
Okay.
Yes, it can be a royal pain in the butt, but once you've compiled Perl static, the static switch that's used for the config args is recycled for everything else, and they will get bigger. But you know, if shippability is your absolute concern, then that's going to be the easiest way. If just having access to the libraries in a reasonable environment is your concern, use the -v. It works perfectly.
Are there Perl modules on CPAN or otherwise that can interface with Docker so that you can use Perl to automate these types of things? Like
Yes. Somebody's got a network connection. If you look on CPAN, look up Docker. There are more than a few of them.
My next question would be, do you have experience with those? Have you used
I've tried a couple of them. In general, the Docker modules on CPAN are about controlling Docker, starting up images, checking the running processes. The question is, what is there for Docker on CPAN? And most of them are for maintaining the running Docker environment, and they're nice. One of the problems you have with Docker, for example, is if you don't have the -rm when you start up a container, it won't be removed when you exit, and you can end up with all these little images that have nothing to do with anything. Another thing that happens, Docker has a really nifty ability to create volumes on the fly. You can get little pieces of anonymous storage and attach them to an image. And the image has nothing in it, it just references that external storage. Which doesn't sound like much, except a lot of times when you're running things, you've got the same piece of code that has to access different data. So what I can do is build an image that has data that drives my website, like different Plaque apps, or whether I'm running this thing in test mode or not test mode, configuration files. And I can have images that all they have are configuration files in them, or reference them. And depending on whether I build myself from this or that image, I will get myself running in test mode or production mode. A lot of that kind of stuff is what you can get from CPAN, of cleaning up all the extra storage, cleaning up all the dead processes, getting rid of images that are no longer referenced by anything. As far as rebuilding it goes, Shell works just perfectly for these because all you've got is the one line that says Docker build mumble. What I usually do is I create a directory of Docker, scratch Docker, and I put the name of the thing I want to build as the base name. And then there's one shell script that does a CD to dir name of $0, and it builds, base name of dir name of $0. And it's one shell script builds all the images that I use, because the Docker file is where you really have the specifics, and that's whatever it is. The other trick, by the way, if you want to build a copy of Perl, another neat way of doing it that I didn't show here because it freaks people out, but it works beautifully, is go to your opt Perl directory and stick a Docker file in it. People that use Docker are thinking about this. What that will do is slurp the current directory as the basis for the image. So what you do then is you do a Docker build, minus tag or whatever, opt Perl 520, let's say. If there's a Docker file in there, that can do the copy dot into opt Perl 520. It can do whatever you need. And at that point, it's going to look a little bit odd because your running copy of Perl is going to have a Docker file in its base directory, but it works beautifully, and it makes it really easy to build that version of Perl in Docker. You don't have to worry about copying it over or tarballing it or doing anything else. Any other questions? Anyone with a heartbeat? Breathing? I don't know. Was this useful? People found it? Okay. I will finish cleaning this up and stick it on SlideShare. So if anyone looks me up on SlideShare, they'll find this version. There's another older version of this that doesn't include quite as much. One thing, quick soapbox. Running a Perl Mongers group is a real pain in the butt because nobody wants to speak, because nobody wants to sit down and write the talks. If anyone goes to my site and finds a Perl talk that's on there, feel free to use them for the local groups. And if anyone else has got talks, put them up on SlideShare where people can get them and reference them as Perl, because it'll make all of our lives a lot easier. But like I said, this will be available on SlideShare tonight after I fix some of the typos I just found in it. Yes?
I have a Docker question for you. My experience with Docker particularly is that as you pull images and play with them, and then if subsequently you erase them, Docker silently leaves data in your temp.
Yes.
Like your temp partition.
Right.
It doesn't let you know at all, and at some point.
What you have to do, the question was that when you run Docker containers, there are volume directories that get created in varlib docker AUFS that don't seem to go away. If you read the Docker documentation on how it handles the -v switch, they say that because the -v switch might be used to store local data, they have no way to delete those. They specifically went out of their way not to implement something because they don't want to find out that they fried something important to people. I think that's dumb, but that's the way they did it. What you end up having to do, and there are examples on the net, is you have to go through those files and look up the ones that are referenced. And Perl is a great way to do this, but you end up with a hash. These file names are directories, are SHA 256 strings. And you have to go through and you can find references to those in your repository, in parts of the file system, and you go into one section of it, and basically what you do is you build a hash of which ones are referenced, and then you look up in the hash and you fry the directories that aren't. And it's a bit of a pain in the butt. But yes, one of the things lacking in Docker now is decent garbage collection. One of the things you do, again, use --rm when you run things, and that will remove the container once it exits. That saves a lot of housekeeping. Another thing is when you do a Docker rm, which removes a container, not an image, it removes the container of something that ran, do an rm space -v, which removes extraneous volumes left over with that container. That is the best garbage collection they've got available today. The saving grace is that most of those directories are trivial in size. The actual directory name, the durant, takes up more disk space than the directory. So you can put a lot of them on the drive without killing yourself. And every so often, you just have a maintenance window where you say everything Dockerish is going to get shut down for 5 minutes and you fry them. And just restart it. I mean, today that's the best you're going to do. Perl would be a nice way to do that because you could look up what's running, what it references. But they're annoying, I know. Any other? That might be interesting. How many people here that use Docker with Perl would be willing to sit down and write a decent garbage collector? We could probably sit down and do it over a couple of beers tonight and make a lot of friends.
Write it in Go.
No, write it in Perl, I would expect.
Isn't Docker written in Go?
I don't know, and I frankly don't care.
Why would you not write the garbage collection in Go as well?
Because I know how to write Perl. I'd have, oops. Yeah, I mean, yeah, it's, well, I mean, at least people, go out of your way to at least write stuff in later than 5.8. But, no, I mean, seriously, if somebody would be willing to blow a beer on it this afternoon or tonight, we could probably write the garbage collector, because all it has to do is look in var lib docker, I forgot which, and it's got the list of the container references, and you can look in the JSON for that, and it tells you what volumes are alive.
So you're suggesting just a plural garbage collector?
Mm-hmm.
Okay.
Well, a Docker garbage collector written in Perl.
For the Perl containers?
No, for all containers.
Not for all containers.
I would just use the Perl language to write it, because I can write it in Perl a heck of a lot faster than I can do it in Go.
Right.
As a matter of fact, you could even run that in a container and do a -v var lib docker and mount it and actually have it reference the thing and do its work. That would be. They actually have documentation at Docker on how to run Docker inside a container. So you can, and there are some, if you're trying to test things in Docker, there are times when you can -v the Docker in the container and test whether your volume mounts are doing what you expect to without frying the file system outside of it. So you can actually localize the Docker effects inside a container to test Docker.
Also done that for making Docker container as a build server,
Mm-hmm.
and then doing the Docker build inside the Docker container with the appropriate volumes to let you.
And then you push it out. And that actually is a decent way to do it, because you can isolate the first trick with the Gen 2, build the Perl on top of Gen 2, push it into something outside, and then use a -copy to get it into a new image, which it's nice because you can isolate it, and it makes it easy to have two processes building different versions of Perl at the same time without stepping on each other. I mean, that's the real thing about Docker that's neat is you can isolate the file systems and have multiple processes running things. The other thing that's pretty sexy about it is you only need to have one copy of anything in the environment when you're running. So you can have opt Perl bin Perl and have Docker containers for 14 different versions of Perl, but each of them has the same absolute path to Perl. They all have the same absolute config files. So now you don't have to play the what version of my running game to find your configuration files to find how you run things. Everything's just one thing. It's an absolute. Any other questions? Yay, we're done. Okay. Thank you.